Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So, sit back, grab a notebook, and let's dive into today's problem. Today we're working out of Elementary Principles of Chemical Processes 3rd edition, and we're doing problem number 3.44. The problem statement says, an open-ended mercury manometer is connected to a low-pressure pipeline that supplies a gas to a laboratory. Because paint was spilled on the arm connected to the line during the laboratory renovation, it is impossible to see the level of the manometer fluid in this arm. During a period when the gas supply is connected to the line, but there is no gas flow, a Borden gauge connected to the line downstream from the manometer gives a reading of 7.5 pounds per squared inch gauge. The level of mercury in the open arm is 900 millimeters above the lowest part of the manometer. Part A, when the gas is not flowing, the pressure is the same everywhere in the pipe. How high above the bottom of the manometer would the mercury be in the arm connected to the pipe? So basically we have to figure out what Z is. Okay, this is the gauge, this is the diagram that they gave to us. Okay, so we don't know what's on this side of the manometer because yellow paint was spilled on it. And so we can't see the other end. So we assume that, okay, it is, the pressure in the pipe is going to be higher than the air pressure, so Z is going to be smaller than 900. That's about the only information that we've got. We do know that when there's no flow in this pipe, that the pressure here is equal to the pressure in this leg. So PA is 7.5 pounds per squared inch gauged, so that's 7.5 pounds above atmospheric pressure. What is Z? Well, we know the density of mercury, gravitational constant. I'm using this ratio right here in order to calculate transfer between pounds per squared inch and pascals. Okay, so let's calculate what the pressure is at Z, PZ right here, at this level. Well, we know in the left leg it's equal to PA, because that's what it is in the pipe. And in the right leg, it's equal to the atmospheric pressure plus the head of mercury, which is H minus Z, okay? Because H is this full length, and then Z is just from here down. So we're just talking about this head right in there. Okay, so H minus Z. All right, well, let's solve for Z. Okay, so we rearrange our equation here, substitute in values, or rearrange a little more. Then we get a function that says Z equals, and it's H minus Z.5 psi. Then we've got pounds, density of mercury, gravity, substitute in all those values, do a unit conversion, and we get that Z is equal to 0.511 meters, or Z equals 5.11 millimeters. Okay, cool. So now we know that. All right, part B. When gas is flowing, the mercury level in the visible arm drops by 25 millimeters. What is the gas pressure, PSIG, at this moment? Well, this one is a little tricky, right? So if the mercury drops 25 millimeters on the right-hand side, then that means it needs to go up 25 millimeters on the left-hand side. So you have to remember that Z doesn't just stay the same. Z changes as H changes, right? Okay? Because the amount of mass of mercury in the manometer stays the same, unless you're spilling it somewhere. Okay? So now we say, okay, what's the pressure of the flow? Well, we know that H has been adjusted by 25 and Z has been adjusted by 25. The pressure of the flow, we just used the same equation here. that we did before, that we solved for before. But instead of using PZ, we're using PFlow. Okay? And we have that all of these values are the same. These H and Z values are adjusted. So we're left with this many pascals. Then we have to turn that into PSIG. And we get 6.54 PSIG. Well, that is it for problem number 3.44. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos. Thanks again, and I'll see you in the next video.